This is your 8.2 pre-calculus video. This is on law of sines. So the first thing is, like on the previous lesson, you had ones with right triangles where you could use sine -1, cosine -1, tan -1 to get angles. And sometimes what you did is you used the Pythagorean theorem, and sometimes what you did is use the ratio of sides. Like, for example, sine is opposite over hypotenuse. Cosine is the adjacent over the hypotenuse, and tan is the opposite over the adjacent. So that's what you did before. Okay, so that was like on 8.1. What you're doing now is you don't have a right triangle, but you still need every side and every angle. So you're going to have maybe an obtuse triangle, or you might have an acute triangle, but you won't have a right angle. Now, the word problems associated with this are about finding the height of a mountain, a rescue at sea, finding the lean or slant of the Leaning Tower of Pisa, and then many others. So those are the word problems or harder problems with it. So your objective is to be able to solve SAA or ASA triangles. What does that even mean? I get to it in a minute about what page to look at if you look at your online textbook. But basically, it's a triangle where you know a side and two angles in that order, or a side between two angles. Okay. Then the other one is the SSA, like two consecutive sides with an angle, and then the applied triangles. Okay, so to start with, if none of them are a right angle, it's called oblique. You either have three acute angles like that, or you have two acute and one obtuse like that. To solve an to solve an oblique triangle means to find the lengths of the sides and the angles. And to do this, you need to know, like, the A stands for angle, the S stands for side. So for example, for the ASA case, let's just make a little acute triangle. And let's just make up an example where I know this is like 32 degrees. I know this side length is like 8 feet. And I know this one is like 38 degrees. So that's what we call ASA. Just as a random example, we know the side that's between two angles. Now the other one is SAA, or they say AAS. Well, that would look like something like, what if we know this is 30 and this one is like, I don't know, 50. I didn't draw it to scale, so let me do this a little bit better. What if we said this one's 60 and that one's 50? There's your AA, and then you need an S, so AAS, this side length. So let's say this one's 10 feet, for example. So that's what your triangles are going to look like. There's another type of problem, which is two sides and the angle opposite one of them are known, which is SA. and then two sides and the included angle, which means the angle in between are known. That's when it's side angle side. Now, some of this may remind you of geometry a little bit. And then there's also side, side, side. Now, it says see page 521 for the figures. You could look at your online textbook or just look right here. So they're showing you ASA first, so it's a side between two angles. And then they're showing you SAA, which is side angle angle. So one of the angles is actually touching the side, but the other isn't. And then on this one, it's SSA, which is two consecutive sides and an angle. And then this one is the SAS, which is the angle between two sides, kind of like the pivot. And then on this one, it's the side, 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 where you don't know any angles, and none of the angles are right angles, but you do know all three sides. Now, what's easy about this one is you're just going to have one major formula. You're going to have a ratio, sine A over A, sine B over B, and sine C over C. Now, sometimes you're going to just use those two and cross multiply, you know, 3 out of the 4. Sometimes you're going to use this and you're going to know 3 out of the 4. Sometimes you're going to use that and use 3 out of the 4. So the main thing is you're going to be cross multiplying. So the law of sines can be used when we have case 1 or case 2, when we're talking about these. So this is the law of sines. So if you only had 3 sides, you cannot use the law of sines. That one's going to be called the law of cosines, which is a different section. Okay? All right. Oh, and I guess that's what I put here. Cases 3 and 4 will be the law of cosines. Now we are going to have to do a height, which is considered B sine A, and we got to compare least to greatest. And for obtuse triangles, the H is on the outside, because if you have something like this, then this is your height. But if you have the acute triangle, then the height is on the inside. So then if A is smaller than the B sine A, there's not even a triangle, it can't even connect. If they're equal, it's a right triangle for the height. If the height is literally the same, H equal B sine A, then that'd be a right triangle. And then this is the part where it's a little different. If you have B sine A smaller, and so you got an extra condition, and if A is smaller than B, then you could have 2 possible triangles. This is where it gets a little complicated, because you can have like a triangle that looks like this, or you can extend one of them somehow. I'm going to have to look at their drawing, but it's right here. I probably didn't do that perfect. Nope. Okay, so they have one that's like, let me just show you. Here's the one that doesn't connect, because A is shorter than the height. On this one, They are the same. And then on this one, this is an obtuse angle. And so that's an obtuse triangle. Or you can have the big acute triangle. And then this is the case where A is bigger than B, would be one triangle. So if I draw this again, there's the one that's acute, and if it's like that, it's obtuse. So it's either the big acute, either the outside acute triangle or the obtuse triangle. So that is where this section is going to get a little complicated. But for the most part, I don't think it's going to be that bad. You also see if the second triangle exists from doing some steps, like subtracting the first angle found from 180, adding that to the given angle, and see if the total is less than 180. If it is, the second triangle exists, and then you need to find 3 more answers. And when I say with subscript 2, I mean like, well, what about side 2? For example, what about A2, B2, C2? So you're going to have extra answers like that. Or sometimes we call it, A2, B2, C2, like that. Now, these capital letters are angles, and these lowercase are sides. So the main thing is you need to know that across from capital A is big A. So if we have like A, B, C, then that means this one here is A, because those are across from each other. And if this one's B, then this one's B. And if this one's C, this one's C. So that's what we're going to be looking at. That's the main concept. Now, most of the time we put signs on top, like sign, and then in other words, sometimes we put all the angles on top, and then the sides on the bottom. But if you do it backwards or upside down, you could do your sides on top and then your angles on bottom. So that's fine. This is an extra slash. And the reason is because you can do the reciprocal. Because if you do the reciprocal to one side, you do it to the other. So you can set any 2 of the 3 together, like when I covered up a letter. Like on this one, you're not using the C's. On this one, you're not using the B's. And on this one, you're not using the A's. Sometimes you have a pair of information on the left, and you cannot use the Pythagorean theorem if it's not the right triangle. Then finish solving the triangle like we did on section 1. And remember, even though it's not a right triangle, everything has to add up to 180. Meaning the angles. The angles have to add up to 180, not the sides. I saw that mistake a couple of years ago, but it's just the angles. Okay, so then let's get started. The first one's talking about similar triangles. And so again, relating it to geometry, you've got a 4 and a 7 that go together. And you've got a 9 and an X that go together. And we just want to cross multiply just to give you a basic skill. So this would be 4x equals 63, because 7 times 9, and then divide by 4, and that's all you can do, and that's your answer. So this is more like, hey, remember, this is how you cross multiply. and that is going to be useful in this lesson. When I was in school, it was called the X method. Y'all could call it the butterfly or whatever y'all say. The next one is the actual formula. So it probably doesn't have a view and example if it's a formula. The whole point is you need to know that the A and the sine A have to be together, the B and the sine B have to be together, and the C and the sine C have to be together. So that's pretty simple. Okay, now let's actually start them. And it looks like on this one, they give you an angle, and a side. Now don't mix up the A that I just wrote. I'm going to spell it out. Because across from this little a is the big A. But this is the angle side. So my first step would be, if this is A, then that's A. We don't know those yet. But if this is B, that's B. So capital B we know to be 45 degrees. That's this one. And capital C we know to be 85 degrees. And then we know little c is going to be 5. Now we know three things. In fact, if you know two angles, the first step's easy. So if you know two angles, get the third easily. So what you do is 45 plus 85 is 130. 180 minus 130 is 50, and that's your answer. So that's what A is. Okay, now the next step, they are going to let you use decimals on this, which is why it's a little easier, because you're no longer using the unit circle. But you need to do your A information with your ones that are known. So earlier when I was talking about pair of information, here's a great example. You have a pair of information here. In other words, you have capital C and little c. So because of that, we're going to do our A's here and say equal, and then we're going to do our C's here. Now, what does it really look like? It looks like sine A over A equals sine C over C. Because we don't use the B's at the same time. So this would then be sine of A, which is 50, over A equal sine C, which is 85, over 5. Now you can't try multiplying or anything. You can't try dividing it, because you can't break up a sine of an angle like that. What you can do is do 5 times sine 50 equal A times sine 85. So that's your cross multiplying, which is what we did at the very beginning. Now, I usually don't write that step. Once you get used to it, you'll know that this becomes your denominator. If you have a variable here, then your denominator is going to be over there. And then you just use your calculator and make sure you're in degree mode. So let's do that now. So first step, right now I'm in radian mode, so I need to click over Now I'm in degree mode. Yep. And I do 5 sine 50 over sine 85 as a decimal, 3.8448. Well, they just want 2 decimal places, rounding to that. And so this would be 3.84. So that's what they got. And now we need to do the B's. Well, here's a hint. Use your pair of information again, because otherwise you may be off by 0.01 and then get upset. So use your C again, since it was the pair of info. So we'll say sine C over C equals sine B over B. So your C's were sine 85 over 5 equal sine B, which was 45 over B. And so that's the number one step I would write out of everything for this, just like this other one was the one step I'd write. So when we do this, now your variable's here, so this sine 85 is your denominator. So do your cross multiplying, so you get 5 sine 45 over sine 85. Sine 45, whoops, I need a 5 in front of that. 5 sine 45. Okay, so we have 5 sine 45 over sine 85. And so I get 3.549. And so that's 3.55, which is what they got. So that's how you do those. So there's one good example. Now, on this one, they put the A here, so here's the little a. They put the B here, so here's the little b. They put the C here. What I do sometimes when I had to do all of these on paper, as opposed to like on worksheets, is I used to say A equal, B equal, C equal, A equal, B equal, C equal, like that. And then just figure out what I know. Okay, I know this one's 8. I know big C is 59. And I know big B is 68. So again, these are angles. And these are sides. So what I know is an A, a B, and a C. Oh, I don't have any pair of information yet. Not given a pair of info yet. Well, I shouldn't even say yet. But what would be your first step? Find your angle. This is going to be the first step. So what we do is 68 plus 59. It's 127. 180 minus 127 is 53. That's your first step. And that is the first blank over here. So now we have, okay, that was capital A. Now we have A is the pair of information, is the pair of information. In other words, we have the angle for A and we have the side for A. All right, now we got to do the B's. So we're going to do sine 53 over 8, and that's the A's, equal, okay, here's the B's, sine 68 over B. So that's how you set it up, and then you say B equal 8 sine 68 over sine 53. Get a decimal. 8 sine 68 over sine 53. 9.287, and then this is 9.29. So that's that answer. And now we do the A's with the C's. So sine 53 over 8 equal sine 59 over C. So then we say C equal, this diagonal is your numerator, 8 sine 59 over, this is across from it, so it's sine 53. So then we type it. 8 sine, you know what, I'm going to be lazy, or you can call it efficient. There. Change this to 59. 8 sine 59 over sine 53 as a decimal. 8.586, so that's 8.59. And that is that one. 8.59. Now, here they're trying to expand your mind a little bit. That's the Greek A, which is alpha. I mentioned that before. And then the capital B is the beta, like an alpha fish, a beta fish. And then this one is called gamma. It looks like a Y, but anyway. And what's weird is across from gamma is side C. So that, looks Greek to me. Yep, it's Greek letters. Okay, so first thing is we know two angles. And so I can say 50 plus 10 is 60, 180 minus 60 is 120, and that is gamma. Okay, that's that one. So that's the easy step. And then what we know is this is our pair of information. So we can say sine 50 over 3 equal, okay, we're looking for B. So sine 10 over little b, because the capital B is the beta. And so then B equal, okay, 3 times sine 10 over sine 50. Okay, so then you go 3 sine 10 over sine 50. I get 0.680. Made me a little nervous at first because my side length was less than 1, but as long as the side length is greater than 0, it's okay. That's pretty general. You do need the triangle to exist, but anyway, as long as it's bigger than 0, it works. And so this is the 0.68. Okay. And then for the next one, we are using the sine 50 over 3 equal, now if we're doing C, we use the gamma, which is 120. Sine 120 over C. And so then we say C equal 3 sine 120 over sine 50. And so then you get 3 sine 120 over sine 50. As a decimal, 3.391. Now, just to prove a point, 3.3915, if you just want 2 decimal places, you don't even use the 5. So don't make it 2 and then round up to make it 40. Okay, so this would just be 3.39 because you round down. Okay, time for a quick joke. So I'll put that on the front now. Sine and cosine are used in everyday life when buying a house. How? Because you sign it, and then your spouse or parents co-sign it. All right, that's good for the day. Hope you have a good one.